Hello, everyone. I'm Jordan Henderson. I've been a software engineer at the HDF group for about 6 years now. And today I just wanted to give a quick talk about a new feature we've been working on in HDF5 to allow people to write virtual file drivers as plugins to HDF5 in the same way that we have filter plugins and vol connector plugins. Next slide. So just a quick recap for people that may not know, HDF5 virtual file drivers, which we refer to as VFDs, allow users to write code to define their own mapping between HDF5's file address space and the actual underlying storage. So in the library, we have VFDs like the Sec2 VFD, which uses POSIX I/O on a single file, the Core VFD that does I/O directly on memory, the multi and family VFDs that write data and metadata to separate files in a different defined way, and a few other different VFDs. And you generally use these VFDs by setting them on an HDF5 file access property list with the generic set driver routine or a specialized routine that each driver might expose. Next slide, please. Here's just a quick diagram I wanted to show going into the HDF5 113 release. This is kind of the current library architecture, with this circle here showing the portion that we're interested in with the VFD layer, showing the Sec2 and MPIO VFDs, and then our S3 VFD writing to the cloud. Next slide. So as for the when and why of the VFD plugins feature, as Elena mentioned, it's going to be available in the 113 release. And for the why, it helps to connect HDF5 to different varieties of data sources. It integrates very well with the library. For example, you'll easily be able to try out any VFD plugins that you write with HDF5's tools and tests and the whole ecosystem. It helps to welcome new contributions to the HDF5 ecosystem, while being able to write these plugins and easily host and build them separately from HDF5. I think it'll bring in a lot of new people wanting to try to write their own VFD. And it helps HDF5 be a bit more adaptable to changing data landscape. Next slide. So I just want to talk briefly about some of the new things that we introduced with this coming feature. The first is this notion of VFD values. These are a new field that go inside a VFD's class structure. They're unique IDs for the VFD plugins, and they're not the same as HDF5's HID TIDs, so we call them values to try and avoid a bit of confusion here. And they're just simple permanent integer values that get registered with HDF5. Some of the ranges we have here reserved, we use 0 to 255 for internal library VFDs. 256 to 511 are for people to use for their VFDs as intermediary values for testing. We basically promise we're not going to use them internally or externally. And then 512 to 65, 535 are ID values that are all reserved for external plugins. So we ask, whenever you write a plugin, if you're ready to make it public, just register with us and we can give you one of these permanent IDs to use. Next slide. Another new concept we're working on are VFD configuration strings. So currently VFDs tend to use runtime configuration data that's set in an HDF5 application, but some VFDs might prefer to have a more arbitrary configuration string. So you can use new APIs I'll talk about to pass these into VFDs. And the HDF group doesn't really impose any structure on these strings. You can pretty much use whatever you like and what'll work best for your environment in VFD. Like I mentioned, you can set these with new API calls I'll talk about. And we also have a new API call that you can use on a file access property list to get the string that a VFD was set up with. Next slide. So a few new API calls we added for this feature, mainly the set driver by name and set driver by value APIs. They both take a file access property list and a configuration string, and they only differ from each other in the fact that one takes a name of a VFD plugin and the other takes one of those permanent ID values of a VFD plugin and tries to load the VFD by one of the two. We also have this third API I just mentioned that just gets the configuration string used for the driver and gives it back to you. Next slide. We also added two new API routines, the is driver registered by name or by value. And these are just useful to help you determine if a particular VFD has been loaded by a particular name or a particular ID value. Next slide. And so finally, I just want to talk a little bit about the feature itself in depth. Next slide. So to write a VFD plugin, first you start by writing a VFD. HDF5 has a couple of example VFDs you can use. These are the standard IO VFD and the multi VFD. Both of these just use standard C, and they don't make any internal HDF5 calls. So you could essentially just treat them as public API code and use them as templates for your own VFDs. We don't really have a template project for creating a VFD at the moment, but you can certainly look at this GDS VFD that I have a link to at the end of the presentation that we've been working on, or you can look at our template vol connector, and hopefully these projects will kind of help you start working down the path of creating your own VFD. Next slide. And then once you've written a VFD, converting it into an actual plugin is fairly simple. You just have to add these two functions to your VFD, the get plugin type routine and get plugin info routine. The get plugin type routine always returns this same value of type VFD, and it just tells HDF5 that your VFD is a plugin. And this get plugin info function should return a pointer to your VFD's class structure. And here the value that I used is just a placeholder, just adjust accordingly for your VFD. Next slide. For loading a VFD plugin, it works pretty similar to HDF5's filter plugins and vol connector plugins. HDF5 will try to look for your plugin in these default plugin paths, which are listed here for the two different major types of platforms. And if your plugin isn't in one of these locations, you can set the HDF5 plugin path environment variable to help HDF5 find your plugin. And then you can either call the new API routines to set driver by name or by value on a FAPL to load your VFD plugin, and then just use that FAPL for your H5F create or open calls. Or, next slide. You can also use this new HDF5 driver environment variable. If you set it to the name of your VFD, HDF5 will try and look for a VFD plugin with that name and then load it and set it as the default on a file access property list. So in that way, the application doesn't need to be modified. All FAPLs that you create will basically just be using the your loaded VFD plugin. And by using this environment variable, it makes it easy to switch back and forth between different VFDs for an HDF5 application if you just want to test something. And we also have this HDF5 driver config environment variable that you can use to pass your configuration string to the plugin rather than using the set driver routines. Next slide. For HDF5 tool support, we've added some new command line options to each of the tools that can use a VFD. Some of them just have one of each of these. A couple have pairs if they're using something like an input and output file. The first option is this VFD value option, where you can specify an ID of a VFD plugin to use for opening an HDF5 file. Or you can use the VFD name option, which is just the name of the VFD to use. And then finally, we have this VFD info option where you can pass your configuration string to your VFD if you need one. Like I mentioned here, it basically works the same way as the options we added for vol connectors to the tools in the 1.12 release. Next slide. For testing your VFDs, there's still ongoing work going on to modify HDF5's testing suite for use with the plugins. We need to do some more separation between internal library VFD type tests and generic ones you can use for VFDs. But for now, it's as simple as setting the HDF5 driver environment variable and the config environment variable if you need to, and then just running make check or ctest as normal. Next slide. Here, I just have a couple of links to documentation that might be helpful. This first one is the RFC for the feature itself. You can see the design that went into it. The second link is a support portal page we have for basically all registered plugins, and we're still working on creating a page for VFD plugins. This third link's support page for all of HDF5's different type of plugins. And finally, this last link, it's an example VFD plugin that we've been working on for people to reference, and it's to allow HDF5 to use NVIDIA's GPU direct storage to essentially do I/O on the GPU device directly using direct I/O. Next slide.
Thanks for that, by the way.
Yeah, of course. Yeah, my last slide, just some contact information if you want to get a hold of me and ask any questions about the feature and so on. The last slide, if there's any questions or comments, I think that's all I have today.
Yeah, yes, thank you, Jordan. There is a comment from in chat from Werner, and I'm wondering if you can address it.
Let's see. Looks in reference to HDF5's, the way that we load plugins. Yeah, I mean, this seems like something relatively simple. I think we have a little bit more work to do on the way we handle plugins, definitely. At first, filter plugins were the only plugins HDF5 had, and now we've been expanding to vol connector plugins and VFD plugins. And so I think it would definitely be good to revisit this. And especially, as Werner mentions, when you have plugins compiled differently between debug and release mode, that often ends up being a problem. I think that's something we still need to look into and fix. So yeah, I think we definitely still have some work to do on plugins.
And I will add this to our Jira database, this request for improvement. Thank you.
Yeah, so any more questions?
We have 4 minutes for questions or comments.
Could I ask a question?
Yes, sure, please.
It's Andy, yeah. Maybe I switch on the video. Just a question to know if this the VFDs could be used to work around the single-threaded model of libHD5 of the.
Well, yes, but
it's a bit of a trick question.
it's still a thing. Work needs to be done to take advantage of multi-threaded VFDs, but this is definitely one of the first steps in that direction. As I mentioned, we need to make VFD layer multi-threaded, wall layer multi-threaded if application uses wall, or convert HDF5 library to be at least allow multiple threads for concurrent reads.
Okay.
Mm-hmm.
Okay, thank you.
There is another question in the chat about the Deos VFD versus Deos wall.
Oh, so next question will be, yes, Jerome will present those. Essentially, yes, one can create a VFD to write to, say, object store. And the example we have is S3. It's read, but it can be also be adapted for writing. So, but there is no Deos VFD at this point. You can use, and Jerome will talk about it, just what Intel provides to write HDF5 directly to DOS using the POSIX layer. And I believe Jerome will talk about it.
Yeah, I can talk about it.
Mhm.